Hi guys, in a previous video we were working through some problems on conservation of energy, and something happened with the iPad and it cut us off in this example. And so we're going to start here from the middle of this example and work our way to the end. And in the previous part of this example we had this car that was going when it got to the ramp, and when it went up the ramp it eventually all of this kinetic energy turned into gravitational potential energy, and it stopped a certain distance going up the ramp. And the question was, how far is that? And so we had to do a couple of things to figure that out. We used the conservation of energy to know that how much energy it started with was how much energy it ended with. It started with kinetic energy, it ended with gravitational potential energy, so we solved for some things. It turns out the mass of the car, which was 1,200 kilograms, didn't matter. And we plugged in what we knew, and we solved for the height, actually, the height that it reached, which was this part of the triangle here. And then we used our trigonometry to find out the length of the ramp that it went up, which was 235.8 meters. Interestingly enough, in places like Arkansas and Tennessee, Colorado, where they have lots of mountains, they have these drive-offs where trucks and things, if your brakes go out, they will put these kind of things at the bottom of the hill so that you can just drive up this in the event that your car can't stop, so that you don't have to, drive off a cliff or something like that. And so this has a practical application, and this just tells the road makers how far or how long this ramp needs to be so that they can make sure that you have enough room to stop. So they don't actually have to make them 235.8 meters long because a lot of that mechanical energy is lost due to friction. So if 38% of that total mechanical energy is lost due to friction, how far would the car go? Well, there's a couple of different ways that you could figure this one out. We're going to go ahead and think about it as if we hadn't done this calculation already. And so we would start in the same place, conservation of energy. The total initial energy is equal to the total final energy, which means that the initial kinetic energy is equal to the gravitational potential energy that they have in the end. Except there's also some lost mechanical energy, which I'm going to write like this, so that we can make sure that we've counted for it. So it used to be over here, but some of that energy has been lost now due to friction. And so when we're thinking about what that's going to mean for my calculations, sometimes that's hard, and sometimes people put numbers in the wrong place. They really like to put numbers in the wrong place, especially when we do labs. And so they end up with numbers that are misplaced. Okay, and so sometimes the best way to think about this is that we're going to be subtracting this from the kinetic energy. So kinetic energy initial minus that mechanical energy that we're losing is going to give us the amount of gravitational potential energy that we're going to keep. Okay, and so what we're doing is we're starting out with 100% of the energy, and we're losing that 38% of the energy. And that's what's going to happen to the kinetic energy that's going to turn into the gravitational potential energy that our car is going to have. And that means that only, 62% of the kinetic energy is going to become gravitational potential energy. So this is how our math is going to change from up here. At this point, everything else is going to be the same. So let's see. I'm going to have my 62% of 1/2 mv squared equals mgh. My m's are going to cancel again, so I'm going to have 62% of 1/2 v squared equals g times h. When I try to get h by itself, I get v squared over 2 g, 62% of that, and then I can just plug in what I know. So I'll have, let's see, 62% of, what was it going, 31 meters per second squared over 2 times 9.8 meters per second squared. And so I have 62%. I'm going to skip this, 0.62 times 49.03. And it's really only 30.39 meters, okay? Actually, that rounds up to 30.40. Hey, this one erases. Am I even in the screen here? There we go. Just to make sure. Oh, gosh, I wasn't even in the screen at all. My bad. Sometimes that happens when I'm not paying attention. Okay. 30.40 meters. Okay, so that's how far height-wise. So on my little triangle there, it's going to go up 30.40 meters, but I really want to know this side of the triangle. So here's my angle of 12 degrees. Okay, so again, this is that's the opposite, and I need the hypotenuse, so that's going to be sine of theta equals opposite over hypotenuse. Let's call that x. Yeah, that's confusing. Yeah, okay. No, we can call it, yeah, let's call it x. Okay, so I want x equals the opposite side over the sine of the angle. So I'm going to put in that 30.40 meters on top over the sine of 12. Let me make sure my calculator's in the right mode. Nope. Glad I checked that. Okay, second quit. Okay, so I'm going to do that answer divided by, hello, that, really? That answer divided by the sine of 12. And I get, this time it's only 146.21 meters. Now, just because I want to point this out, if you had already done all this work and you knew that it was going to be 62%, 235.8 times 0.62 ought to be the same thing. Oh, look, it is. So I could have just skipped all that and gotten the same answer. But this is how far it is. So when my road makers are making this little off ramps for when you run, for when your brakes are out and you're going downhill and you don't want to, you know, run into like buildings or a town or something, and you want to go up this way, it doesn't have to be the whole 235 meters. It's only at 146. That's a whole like 100 meters less. Okay, so that's a practical application of this one. But this can be done anyway. Just you have to make sure that where the energy is lost is on the right side and that your percentages are in the right place. That's the tricky part of applying conservation of energy when you are losing energy in an open system. Okay. If you have any questions, make sure you ask. Conservation of energy is going to be used on the AP Physics test like all over the place. Okay. Make sure you know how to apply it. Thanks for watching.